All right, welcome to part 2 of the Finding Slope lesson. So in the last lesson, in part 1, we talked about slope being the steepness of a line or a ratio describing how steep an object or line may be. We talked about, so let's do our quick recap, the fact that slope is positive when it's going up from left to right. So we also noticed when our line was increasing, remember I put the little man on the left side of my line, if I could tell that he'd be going up that line from left to right, it's a positive slope. And slope is negative when we are climbing down a line from left to right. So that's a negative slope. We also referred to slope as the rise over the run. What we didn't really get into very much was the fact that the rise is the change in your y coordinates. Now we did look at that on the grid. I just didn't exactly use x and y as variables yet since it was our introduction to it. But if we're rising up or down, that is on our y-axis. If we run right or left, that is on the x-axis. So the rise can also now be referred to as your change in y's, and the run can be referred to as your change in x value. So today we're going to get into really this change in y and x coordinate values and using slope and finding slope using a formula. So it's nice to be able to count to rise and run. However, life isn't always that clear and simple for us where it's always given on a nice clean grid. So when it's not as obvious what the slope might be, maybe we don't have a graph of the line, we're just given points of the line, we can calculate a slope by using this formula. So m refers to slope. So slope's variable, or the variable we'll always use for slope, is the lowercase m. That always represents, well, almost always represents slope. It will this year, mathematically speaking, for us in Algebra 1. M equals the change in y's. So what we're seeing here is what's called y2 minus y1. So this implies your second y minus your first y coordinate values, divided by x2 minus x1, which is your second x value minus your first x value. So if you find the change in your y's by subtracting them, finding their difference, and you find the change in your x's, again, subtracting the x values, finding their difference, and set that up as a ratio, that is your slope formula, and will give you the slope of that line. So to find the slope using the formula, what we'll do is we'll start by finding 2 points on the graph. And you want to always look for points that are nice, clean grid intersections like the ones I have noted here. If they're not, hopefully the points are given to you or you actually know the point values as decimals or fractions if they're not nice, clean grid line intersections, which is fine as well. So what we'll do is once we get our 2 points, we're going to write the ordered pairs for the points and use those x and y values to substitute into the slope formula, simplify the formula, and find our slope. So here's our first point. We have the point -2, 1. And here's our next point. We have 0 for our x and -3 for the y. So our 2 points, I'm going to rewrite over here. And let me note right here that it doesn't matter which order I put these points in. If I had put 0, -3 first and -2, 1 second, that would have been perfectly acceptable. Before we get into substituting the values into our formula, I do want you to take a look at this line. Notice it's going down from left to right. So this indicates that the slope should be negative. And I want you to make that notation to yourself or just remark on that before you actually find your slope, because that's a nice quick way to check if your slope actually matches what you were expecting it to be once you actually find it. And that can be a good way to maybe find any potential errors you may have made when you're finding your slope. So this should be a negative, so hopefully when we're done we will find that to be true. Okay. And 0, okay. So what we'll do is if this is our first ordered pair, I'm going to call this x value x1 and this y value y1. And if this is our second ordered pair, again, I'm going to call these now x2 and y2. So what I'm doing is I'm naming the points, and this would be helpful for you to do as well when you're finding the slope. Now we're going to fill in the values to our formula. So m equals, y2 is first. So y2 comes from the y value of our second point. I'm going to put that first, minus y1. And y1's value is the y of the first point, which is 1, over x2 minus x1. Now you'll notice x1 is a negative 2. So we actually have a double negative here, minus a negative 2. And it's important that you write that. Now when we simplify, negative 3 minus 1 is negative 4. 0 minus a negative 2 can be written as copy, change, opposite, right? So 0 plus 2 is 2. Let's simplify this further to negative 2 over 1, or you can just say the slope of the line is negative 2. And we can see it did match that negative value we were expecting to see because the line was going down from left to right. So the slope of this line is negative 2. It's a fairly steep line, and hopefully that makes sense with your ratio and matches. All right, let's try another one. So this time we're given 2 points, but we are not given a graph of the line. So you would not be able to check the slope like we may have here. Here we could have counted down and over and seen that it was a rise of negative 4, a run of positive 2, and checked using our rise over run that it was negative 2. Here we're not given the graph. So what we'll do is we are going to start by labeling the points we're given. We're going to find the slope between the points 3, negative 4, and 2, 5. So I'm just going to call this point x1 and y1. And again, it doesn't matter which point you name as your first point. You could choose to make this one your x1, y1. I'm not, so this one's going to be my x2, y2. From here, we will fill into our formula. Well, I guess I should maybe let you guys fill in first, and then I'll reveal it. So go ahead and fill into your formula, and then take a second to do that, and we'll check how you filled in your formulas. Okay, so y2 minus y1 in my scenario would look like what's over here on the left, 5 minus negative 4. Then the x value subtracted would be 2 minus 3. Over here, I want to show you on the right that just to reinforce that it doesn't matter which point you name as your first or second point. You may have chosen 2, 5 as your first, 3, negative 4 as your second, meaning this is your x1, y1, x2, y2, and that would substitute into this slope formula. We'll find that no matter how we set it up, we will all get the same value at the end. So 5 minus negative 4, these really become addition to be a 9 over 2 minus 3 is negative 1, so slope of negative 9. Here you can see negative 4 minus 5 is negative 9, 3 minus 2 is positive 1. Again, a slope of negative 9. So the slope is negative 9. You can leave it over 1 or just leave it as negative 9. That choice is up to you dealing with slope. Oftentimes in the beginning, students will like to leave this 1 here just to reinforce the fact that this means we rose down negative 9, but we ran 1. Sometimes when we don't see that 1 on the bottom, we may forget that there is a run of 1 implied there. So if that helps you, you may leave it over 1. Okay, so we've practiced using the formula. Let's take it a step further. In this scenario, we're going to be actually told what the slope of the line is, but we'll be missing one of the coordinates for one of the ordered pairs. So here we're going to find the value of r so that the line through the point r6 and 10, negative 3 has a slope of negative 3 halves. So what we'll do in this scenario is use the formula we have and fill in or substitute the values we know into the formula. So what's going to help here is identifying one of the points as your first point and the other point as your second, and labeling your x1, y1, x2, y2. So I'm going to call this one x1, y1. and this one x2, y2. And in doing that, and here's our m, what I'm going to ask is that you set up your slope and write this as a fraction in this way in the equation. So here I'm going to have -3/2 equals my y2 of -3 minus my y1 of 6 divided by my x2 of 10 minus my x1, which is r. And hopefully you've set the slope up vertically like I've just asked, and you notice maybe that this is a proportion that we've created. So even if your slope is a whole number, I would write it over 1 so that you still have this proportion set up where we can now cross multiply and set up the equation work to solve for that missing value r. So I would set up 3 times 10 minus r equal to 2 times -3 minus 6. You may go ahead and simplify that right to -9 from here. So distribute on the left. 2 times -9 on the right is -18. We will add our 30 to both sides, divide both sides by 3. Here I'm just solving for r to find r's value to be 4, meaning that the point, the second point on that line would be the point 4, 6, because r was for an x value. So r equals 4, and we've solved this problem. Here's our next one to find the value of r so that the line through 1, 4 and -1r has a slope of 2. So I'm going to let you set this one up on your own, giving you again that little hint. This is a whole number, and we want a proportion set up. So when you're replacing your slope for m, write it as a fraction over 1. You can write any number over 1 and not change its value. That will help you when you get to cross multiplying. Set this up, solve it, click pause on this video. When you're ready to check, we'll click play and see where you are. Okay, so hopefully your setup looked like this. If you chose to name this as your x1, y1, and that is your x2, y2, then it would look like this. So I'll just show 4 minus r over 1 minus -1. You still would get the same value when it's all said and done. But here we are, cross multiplying. We can simplify the -1 here. -1 minus 1 to all be -2. -2 times 2 is how we got the -4. Here we're distributing the 1. Solve for your r, and r equals 0. So this point would be the point -1, 0 over here. And you're done. Okay, next we're going to look at finding the slope from data in a table. Oftentimes our linear equations or our lines that are graphed will represent data points or points that create that line. So when we have linear data, that data would make a line so we can find the slope or rate of change of that data. So when you have a table, you can see in this case we have the time walked versus the distance walked. You know, the units aren't given. We're not so much into exactly what the scenario is. However, we can see this is our first column, so we know those are our x values. This is our second, so those make up our y values. So in this data table, this can translate to a set of points. Our x, y point, or coordinates make up several ordered pairs here. And this is all the data that's given to us. And so for finding the slope of the data, what we'll do is pick any two of the points from this linear data and fill it into our slope formula. I'm going to use the first two because they have smaller numbers and they're easier to work with, but you can use any two pairs of points. Pick one to be your first point and one to be your second. I'll make that my first, this my second. Again, the choice is yours. What's important is that you're just consistent in pulling from the same point first each time. So if I make my change in y's and I write 8 minus 4, I'm subtracting 8 minus 4. These are my y's. What's important in the denominator is that since I pulled from the second point here first, I need to start with 2 first in the denominator and do 2 minus 1 in the denominator. That's the biggest thing with slope formula, is always just pulling from the same point first. So you can see 8 and 2 may come from the same point, and they are first on my slope formula. So from here, 8 minus 4 is 4, 2 minus 1 is 1, so we have a slope of 4 for this set of data. You may notice that because this data is increasing by the same exact amount all the way through, that another way to see this slope would be to add 4 every time, adding 1 every time, is to see that the change in y's was a change of positive 4, and the change in x's each time was a change in positive 1. So another way to arrive at this slope is to just count and see that change in y's all the way through. I caution you, however, to do this because sometimes our data is not given, we're not given every single point that would be on the line. Therefore, you may have not been given this middle point here. For example, 2, 8 may not have been given there, and you might have seen a slightly or a different change in y's versus x's if we had more data and certain points were omitted. You may be misled into what the actual slope of that line might be. So I encourage you to use the formula. Maybe you can check it by doing an eyeball test of seeing that change in y's versus change in x's. Here's another table of data to find the slope from. I'll give you a moment to choose 2 of these points, fill them into your slope formula, find the slope, and then click pause. When you're ready to check, click play. Okay, so you found the slope of your data. I, again, used the first 2 points. They were the smaller values, so I tend to just use easier numbers when I can. And we should have gotten our slope to be 39 over 1. You may have just said m is 39. That would have also worked. Okay. The last thing we're going to look at are different types of slope scenarios, especially including horizontal and vertical lines. So positive slopes, we have discussed, they go up from left to right. So a positive slope will always move in this direction. A negative slope will always go down from left to right. Again, imagining the man going down that line, that's always going to be a negative slope. Let's talk about slopes for horizontal and vertical lines, though. So here's an example of a horizontal line. You can see here it will be a slope of 0, but I want us to go over y. I'm going to throw 2 points on this horizontal line, and I'm making up the value, but I'm going to say this point's value is 1, 3, and this point's value, let's say, is 4, 3. Okay, so I've written 2 points that could be on this line, assuming it's intersecting at a y value of 3. If we go ahead and input these values into our formula, so x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. When we simplify our formula and find 3 minus 3 is 0, 4 minus 1 is 3, what will always happen with horizontal lines is we will find that we always get 0 as the numerator's value. 0 divided by any number is 0. So horizontal lines will always have a slope of 0. Horizontal line equations, which we'll get into a little bit more in our next lesson, are also always written as a y value equals the number, and this would be the equation of a horizontal line. So in this equation, or in this scenario, I'm saying this horizontal line's crossing the y-axis at 3, so the equation of the line I've created would be y equals 3. So horizontal lines are always a y equal to a value wherever they cross that y-axis. So if you see a y equals a number linear equation, you will be allowed to assume that the slope of that line is 0. Should make sense because we're not going up or down. We're going side to side. We're not increasing or decreasing, so it has a slope of 0. The next and last kind of line we'll look at is a vertical line. Vertical lines have what's called an undefined slope. So again, let's talk about that. Let's say this is the point 4, 1, and this is the point 4, 3. Again, let's find our slope. So I'm subtracting my y's and I subtract my x's. In this scenario, I get 2 over 0. This time, the 0 ends up being on the denominator. This is a huge no-no in math. I always say we are mathematicians, not magicians. We cannot take a number like 2 and divide it into 0 parts and make it poof disappear, right? That number is there. So in math, it is illegal to divide by 0. We cannot do it. We cannot comprehend what that really means. So because 0 is on the denominator, and it always will be for undefined lines, for vertical lines, their slopes are undefined. And if you're asked to write the slope of a vertical line, you are expected to write the word undefined. It does not exist, or is not comprehensible. Vertical lines are always written in the form of x equals a number, and the number will be, or that value is wherever your vertical line crosses your x-axis. So you can see that of the points I wrote in this scenario, they all have x's of 4 because that's where I'm saying it crossed the x-axis. So the equation of this line would be x equals 4, which I'm not able to write right now, but x equals 4 would be that vertical line's equation. So those are special scenarios, slope of 0, undefined slope, that you will be expected to know. All right. So the last little bit here, just to recap a few things. Because slope is a ratio, it should never be written with decimals in it. So if you ever are calculating a slope and you find that your slope has a decimal in it, you should work to get rid of that decimal. And we can always get rid of decimals by multiplying our numerator and denominator by a power of 10. We are allowed to do this because 10 over 10 really simplifies to 1, and anything times 1 itself. So you would rewrite this as 1/50 and say that this is the slope of the line. So never, never allow decimals to stay in your slopes because they are ratios. Ratios are a comparison of two whole numbers or integers. So always leave slopes as simplified improper fractions, again, because they're a comparison of two numbers. So never write a slope as a mixed number as well. So those are just a few key things about slope. If you are in class, we will be watching the Slope Dude video. We also will play a little game, and we have a fun little rap that goes along with slope. And a fun song. So there's lots of little slope activities we'll do in class. However, you now have the tools to be able to calculate a slope from an equation, and that's what we focused on in part 2 of this lesson. All right, thank you.